This reaction is from chapter 16, so I'll have the chapter up here, I'll put a reaction up. And what I'd like you to do is hit pause, so take this down, write this down on a piece of paper, hit pause, and then give me the product and name the reaction if you want. So I'm going to stand here for a second, I'm going to assume you've hit pause, and then I'll work the problem. Okay, now that you're back, and seriously, this doesn't work if you don't actually work this. So we have here an S-cis diene. Dead. And a dienophile. And this ought to be a reasonably good Diels-Alder, because you've got an electron withdrawing group on the dienophile. This is a mild electron donating group on the diene. And so the reaction is going to be between the diene. Excuse me. I'm not going to stop. You don't get a lot of production value with Paul Jones productions. Okay, so I'm going to number the diene. 1, 2, 3, 4, 5, and 6. All right, and now you have to figure out where the substituents will be. You don't have to worry, like that carbon is going to end up bonded to 1 and 4. The only atoms that are going to react here are the dienes. And so I'm going to draw this around like so. All right, that's carbon 1, 2, 3, 4. And now the dienophile is going to line up. Remember, so if you have a substituent, one substituent on the diene and one substituent on the dienophile, you either get 1, 2 or 1, 4. Right? If the substituent's on the 1 on the diene, it's going to be 1, 2. So this is going to go like so. 5, 6. The mechanism is like that. So carbon 1 and 6 will become bonded to each other. Remember, you're going to get a cyclohexene. Every Diels-Alder is going to give you a cyclohexene. All right, this is, let's number these. So 1, 2, 3, 4. That's going to be 5 and 6. Carbon 6 is going to have a cyanide. I'm going to put that down. Carbon 1 has a methyl. Carbon 1 also has a bridge to carbon 4, that carbon right there. Okay, and so that's going to be here and up. Okay, so the diene 1 through 4 reacts with the dienophile 5 and 6. Everything else stays attached where you would expect it. You can also draw this as a bicyclic. Right, so there's another way to draw that. I'm gonna put in the carbons now. So that's 1, 2, 3, 4, 5, and 6. So cyanide is going to be in the exo position. It means it's down. It's closer to the longer bridge, the alkene. Basically, this substituent, if you have a pi substituent on the dienophile, it's going to be closer to the new pi bond. Let me make sure I've got all that on screen. Yeah, it's on screen. Okay, so there you go. That's the answer. Always find your diene and your dienophile and make the Diels-Alder between that.